What is up, guys? This is the Redstone Scientist here, and I have got some pretty interesting stuff to show you today. We're going to be talking about random number generators and data analysis of them. So to begin, let's say you're making a map, all right, and you need a random number generator. But you want to be picky. There's oftentimes you really want to be picky with what kind of generator you choose. A lot of times maybe you want something is more probable than another one, or so on. There are a lot of different options about what you could have. Maybe you don't want it to be entirely random. Maybe you want it to take a certain number of times in order to get all of them. Maybe you're going to use the random number generator more than once, and you want to get every single output at least once. The point is, you want to be able to browse your random number generators and choose the one that's right for you. So I've come up with a couple ways to analyze what the random number generators, how they work, the randomness, or rather the pseudo-randomness. For those of you that are a little bit more into the math, nothing is really random. It's pseudo-random, which means that now Minecraft, I believe, don't take my word for this, but what a lot of games do, and I assume Minecraft does, is the randomness, anything that needs to be random in the game runs off of your computer's clock, or rather the client's clock. And then what that means is, whenever you want to get an output or a value, so let's say you're using a dropper, and it needs to decide which of the slots to select, it basically stops the clock on exactly when you push the button, and to simplify it, it takes the numbers in the 1,000th decimal place, in like the millionth of a second. It takes those two numbers at the end of the number in those millionth decimal places, and it uses those as the output. Maybe I didn't explain that very well, but I think that's how Minecraft works. The point is that Rixis, I have to double check on the name, Rixis or something like that, has created what I believe to be the absolute best random number generator I have ever seen. So let's take a look at how it works. You push this button, and it outputs an output. By the way, there's going to be some pretty bad lag in this video because I got a lot of stuff going on. Now, the point is, let's remove this piece of redstone and let's watch what happens. So we push this button, and here's what happens. We've got this whole row of stone, and only one of them is redstone. Now, the way this works is, thanks to new NBT tags, NBT containers, or rather, these can store NBT data, we can now put command blocks into dispensers, and they can place them. So here, in the first dispenser, we've got a left command block and a right command block. This is the left command block. So what this does is it's filling this entire left column with stone. All right, then there's one tick that happens, and then this dispenser has 6 command blocks, 1, 2, 3, 4, 5, and 6. This happens to be, the command block that's dispensed is 3, 4, 5, 6, this looks like row 6. So what this does is it fills from here to here with redstone block, but if you notice, it replaces stone too. So that's how we make sure that it only replaces. So basically what it's doing is, it's selecting whether it's going to be the left or the right, randomly. And then it randomly selects which of the rows within that column it's going to select. So let's watch this again. Oh, sorry, first we have to clear it with this button. Let's do it like this. So as you can see, the command blocks are dispensed and then immediately taken away by these command blocks. So, look, this time we got right, and this one was selected. Now, I expanded this a little bit. Actually, first I added these command blocks, which say what the output is, so we can get a little bit of a better idea what is happening. So this time we got output 12. It's lagging right now. This time we got output 11, and so forth. So what I did was I expanded it a little bit so that there were 18 outputs. And then I added a lot of stuff onto it. So let's take a look at what I've done here. So this is my recreation of it right here. You can see the basic parts of it right here. So let me show you what's happening. The first thing is yes, this random number generator works the exact same way. What's going on? Okay, this random number generator works the exact same way as the other ones. I don't know why it's lagging so badly, probably because I'm recording. You can see it's kind of inching through the repeaters there. But it normally goes a lot faster than this. There we go. And it's constantly generating numbers. And what I want to test is, how many times do I have to generate a number until I get every one of these outputs at least one time? I'll say that again. I want to keep generating numbers until I get every single one of these outputs at least once. By pushing, by pushing tab here, we can see what number we're on right now. So actually, as soon as it comes around, there we're on 64. So it's, as of now, we've hit every output except this one in these 64 times we've generated a number. Now, the way it tells if you whether or not it's generated at least once is these command blocks. So this is the only one left right now. It's doing a set block on itself for air. So it basically, when this command block is activated, it just disappears. Now, the other thing is over here, I'm doing a test for blocks. That's these two command blocks. And I'm testing to see if this row right here is air. And it is air right now. And this is almost all air, except for this one command block. And that's how I tell whether all outputs have been selected at least once. And that activates this AND gate. And I'll go into what that does a little bit later. Now, over here, in addition to removing those command blocks to test if it's happened at least once, it also activates these command blocks every single time. And what each of these do is it summons a sand block 25 blocks up, you can see right here. And it falls down here, and what this represents is, this is a visual representation of how many times each of the outputs has been selected. So you can see the yellow output has been selected far more times than the blue output. Now, something else I want to mention. Random generators can often play tricks on you. Because first of all, remember, nothing is truly random. And what we expect random to be that it's going to either be all wacky, different amounts of selections, or that they're all going to be exactly the same. Now, technically, as we approach closer and closer to infinity, these should become closer and closer to being exactly the same height. Now, also, it may appear to us as if it's definitely not random, because maybe one is clearly favored over the other ones. But remember, it's random. So it just so happens that this scenario is one is favored over the other one. In other words, it doesn't prove that it's not random. All it's saying is this is an unusual situation, and, oh, it's interesting to us because we're noticing a pattern. But it doesn't necessarily negate its randomness. But anyway, this is a visual representation of one of them. Then what happens, I'll go into how it works later, is that these, after every single one of the outputs has been selected, it just was, all of these sand blocks are cloned. It should be starting again pretty soon. I don't know why it's not. What's going on? There's some pretty bad lag going on. Okay, here we go. It just started over. So those sand blocks, so you can see it refilled them all with these command blocks. The sand blocks are cloned over to here, 256 blocks up, and they are allowed to fall onto here. Now what this is an accumulation of all of the different tests I do. So when I say test, I mean each experiment to see how many times it takes to get each output at least once. So this is an accumulation of all of the outputs, how many times they've been selected. And I've got markers here. You can see this is 30 times the white has been selected and so forth. And then once it reaches 100, this front row represents 100. So this white has been selected 100 and hold on, 100 and 99, 98, 97, 96, 196 times since I reset this. And the same for the other ones. It measures how many times they've been selected. So that's another visual representation of the data. And again, it's going to play tricks on us, and we might say, oh, that's not random at all. But really, it is. It's pseudo-random, rather. Now, another thing I have going here is every time, you can see up there in the top, that's how many numbers I've generated so far in this test. And I'm recording how many that is. So here's the first one. So in this case, each gravel represents 10 rounds, and one sand represents 1 round. So in the first test, I did 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2. So it took 82 numbers. It took 82 rounds. 82 numbers were generated before I got every output at least once in this first test. And this represents how many times it took on the second test, and the third test, and so forth. So this continuously records the results of each test, how many numbers I have to generate each time. Over here, this is a representation of how many tests we've done overall. So since I've reset the whole system, we have done 57 of these tests. So we have selected every output at least once, 57 times. So that's about all that's Oh, and then also on the side here, on the right-hand corner, the right side of the screen, you can see the average. And what this is this is all of these stacks, all of the results of all of the tests are added together and divided by the number of tests, and that's how we get the mean, or the average, which is in the right side, which is 63 right now. Now, of course, there are going to be outliers, but that's one of the flaws with this design. I'm working on what do you call it? Mode, or median, sorry. Stuff like that. But that's not done right now, as of now. But, so I've got a couple things to go over. We've got how does this work? How does it represent the data? How does it do the tests in the first place? What's going on? Okay, how does it do the tests in the first place? How does it clone it and stuff like that? How does it record? And how do these work, especially? And especially, how does the average work? So let's start with one test. So this button is pushed, and the whole random number generator gets activated. Now, this redstone line here, first thing that happens is this command block gets activated, which is adding 1 to the rounds. Now, rounds are the number of numbers we've generated. Okay, so it adds 1 to that. That's how this number at the top keeps going up. Now this redstone line happens. So what this is doing is first, this tests for blocks, tests to see if this row is air, and if this row is air. That's these two blocks right here. And if both of them are air, then these two torches turn off, and this AND, just like right now, this AND gate gets activated, and that locks this repeater, which activates the next line. So you can see after this test, there's a delay, and it goes around through this repeater and starts the random number generator again. But when the AND gate is activated, it locks this repeater so that the test can't happen again. And that way it can analyze all the data first before we start over. You see it just started over now. So when the AND gate gets activated also, what happens down here is, there's also some command blocks clearing the sand and stuff. So it goes down this redstone line. So the first thing that happens here is, this is for the average. Now, this is using new 1.8, in the new snapshot scoreboard operations. So what this is doing is, this is a fake player named Average1. And what it's doing is it's taking his score of total and adding to it with the score of rounds right now. So basically, the score of total is the accumulation of how many times we have generated, how many numbers we have generated, period, over all the tests. Over all the tests, how many numbers have we generated, period? And so that accumulates, because after each test, rounds gets reset, but total doesn't. I hope I'm explaining this well. Now over here, it also adds 1 to test runs for average 1. And test runs is keeping track of how many tests we've done overall. So every time this AND gate gets activated, we've done 1 test. So it adds 1. The next thing that happens is these command blocks are cloning the sand to the appropriate places over here, and that sand is falling down. The next command block is placing a redstone block over here, actually. I believe it's right here. It's replacing this with a redstone block. And what this does is this color codes all the sand. So this does a fill all the way up this stack, and wherever it finds sand, it replaces it with wool with a data value of 9. And same thing for all of these. So that's how it gets color-coded. Let's see, are we nearing an example of that? No, I'll show you that later. So that's how that works. The next thing that happens, or gets activated rather, is another block is set. And that is in this clock over here. Now, I know I'm going pretty quickly, but it's kind of complicated. So this clock gets activated, and what this does is, this is a T flip-flop by testing for an unpowered comparator with a data value of 3, which 3 means it's facing this direction. And this is a T flip-flop, so it activates, and it pushes this piston out, which activates this comparator clock. Now this comparator clock is in charge of creating these stacks. So the first thing that happens is it tests to see if we've got at least 10 rounds left in our scoreboard objective. And if we do, it does a execute command. Now, over here, I've got minecart command blocks that are moving along over here. Now, this one is gravel, and this one is sand. So what it does is, it first executes a command at the location, at the location of the gravel minecart. And at that location, it does a set block where it is in the line. It does a set block right under it of a redstone block. And what the minecart command blocks commands are actually summoning gravel and sand above or right next to them. So that's how that works. And then every time it places a redstone block, it it removes 10 from the rounds. So it's sort of it's processing the number of rounds, and it's removing it after it's done processing it. And then it does another execute command that replaces the redstone block that activated the minecart command block with sandstone. And that it then locks this comparator so that it has a chance to reevaluate whether we still have 10 left in rounds. And if we do, the whole process starts over again. Then, once we're at 9 or fewer, or rather, once we're at 9, this tests to see if we have at least 1 left, and if we have maximum of 9 left. And then this is the same thing. This does an execute command at the minecart command block named sand, and it places the redstone block. It removes 1 from the rounds, and then we replace it with sandstone, and it locks it to do it again. So that's how that works. I know I'm explaining this very quickly. Hopefully you're able to follow along. But that's how it works. So let me do scoreboard, objectives, set display, sidebar, rounds. Now we can see as soon as this is finished, hopefully this will be finished soon. Let's hope. We can watch it process. Let's see. I'm going to cut away, and when it's happened, I'll come back. Okay, here we go. Now, that just finished, so now we can watch this clock get activated. Okay, here we go. Now this is activating and it's testing. Okay, now you can see in the right-hand side it's going down. All right, well that was an okay example, but hopefully that made it make a little more sense. Now the next thing that happens is it says, okay, now we're going to test for if the rounds are 0, which means that we finished summoning the stacks. Okay, yes we have. So it activates this. Now this teleports all entities that are minecart command blocks in -3 in the x-axis. And that's what moves it down the row to the next slot right here. And then when it gets here, it gets teleported to the next row. And that's how that works. When it gets to the end, all of this gets cleared and it continues from the beginning. So hopefully that made a little more sense about how these stacks work, how it records the number of rounds it took for each test. Now I'm going to address how the average works. Alright, now this is going to get a little bit more complicated. So after the test happens, now the average updates dynamically, actually. Hold on, let's set this back again. Okay. The average updates dynamically, which means that after every test, the average updates to whatever the new average is. So after every test, it places a redstone block right here on this piece of stone. What is it called? Granite. On this granite. This command block removes it after 3 ticks, and here's the order of stuff that happens. So, first, we're going to set the average score of, average 1 score of store to 0. Now, store serves as a memory slot. Next, we're going to do a operation. We're going to set store equal to total. So now total and store have the exact same value. We're by adding total to store. Then we are now, unfortunately, we cannot, if this makes sense, we cannot just divide with the operation and get an output that we can then assign to whatever we want. We have to divide through, which means that total is going to have a new value. So we're dividing total through test runs. Now remember, after every test runs goes up by 1. So we're dividing all of the rounds added together by the number of tests. So by the number of numbers. So we're dividing it through test runs. So now total has been affected. So now total is now the new average. But total is not supposed to represent the average. Total is supposed to represent the total. That's why we stored it in store. So first what we have to do is we have to tell it that we have to reset average, so we're setting average to 0. And then we have to tell it, no, total is supposed to be the total, and average is supposed to be the average. So now what we're doing is we're adding the value of total to the value of average. And now remember, average is 0, so now average and total are exactly the same. So now average is correct. Average is set to the correct average. Then we're setting total back to 0, and finally, we're adding store back to what total is. So in other words, total is now back to where it was originally. Total now has the correct value of the number of rounds we've done, because store was storing that number for us. Set to 0, so we can go through that process again. I'm still getting used to explaining redstone stuff, so I'm sorry if this isn't making sense. It is kind of complicated. So that's how the average gets updated. Over here, and then this long redstone line also is what makes the round happen again. It activates this lapis right here, which activates the mechanism again. Now, what is this stuff? Okay, this is testing for the hundreds, to make the hundreds go there. I think that's pretty self-explanatory. How does this work? What this is doing is these are a lot of clocks testing for. This is also represented by 10s and 1s. So we're testing for right here. This is easy. We're testing for if it's at least 10, 20, 30, 40, 50, 60, etc. But this is a little more complicated. This is testing for. This one is testing for whether the score of test runs is anywhere from 1 to 9, because this is supposed to fill up. It's not just going to be it's not 1 is not selected. Not 1 is just selected. We want this to fill up like it's a beaker. So this is testing if it's 1 to 9. Then it's also testing if it's 11 to 19. It's also testing if it's 21 to 29, and so forth. This one is testing whether it's 2 to 9, or 12 to 19, or 22 to 19, and so forth, and up the line. Now that is so that no matter what it is, we have an accurate representation of what the second digit is. That's how that works. I hope I explained that well. Now that I have shown you all of this, I'm going to show you how the clear works. Obviously, the clear for this, it resets all the scores, all the averages, and everybody's score, all the fig scores and everything. It resets it, and it removes all the granite under these stacks so they can all fall down. And then it removes the minecart command blocks and does a summon command to place them back at the beginning. Then the clear command over here will do a fill and replace for everything here, so it's going to find any instance of wool, or in this case stone and dirt, and it's going to replace it with sand. And then it's going to remove the thing at the bottom here, which is going to make all the sand fall down. All of this line is what turns it back into sand. So I think that's pretty much it. I'm really sorry if I haven't explained this well. I'm still learning how to still kind of figuring this whole thing out. This is a new channel. But I'm hoping that you guys can give me some tips on how I can make this clearer. Also, I want to have anybody's idea, if there are any ideas on how I can detect whether or not there is an outlier. And I want to be able to remove that outlier from the equation for the average, but I also want it to activate a thing that will do a, what is it called? A something unit, a summative. It's like it's a sigma. In other words, in order to find the bell curve, I want to be able to find the bell curve of the average, which takes care of the outliers. If anybody knows what that means and can help me figure that out, it does involve creating a square root algorithm. So hopefully you guys understood everything that went on here. We can see that happening here, and it's about to get color-coded. There, just happened. And then the hundreds just happened. Oh, okay, here's another one. I don't know why it's lagging like this, but here we go, it gets color-coded. Anyway, I hope you understood all this. I might revisit this in the future. This is definitely, that one I showed you is definitely the best random number generator out there. I'll put a link in the description to it. Again, any suggestions, any comments, any concerns, please post in the description. I'm still getting used to this stuff. Please tell your friends and subscribe. And that's about it. Thanks for watching. So I'm going to do a clear. Alright, and then we're going to clear this. Where's the lever? Over here. So, thanks for watching, and again, comments, concerns, questions, anything at all, please let me know. I'm dying to hear what you guys have to say. So, that's about it. Thanks.